Assalamualaikum and hi, my name is Muazzar Kasham bin Zaidi and I'm going to present about my final year project. The topic is molecular interaction of nicotinamide and cinnamic acid co-crystal using Crystal Explorer. First of all, what is co-crystal? Co-crystal is a crystalline structure composed of at least two components, whereas the component may be atoms, ions, or molecules. And next is what is co-crystallization. Co-crystallization is a process whereby two or more different species coexist in a lattice through intermolecular interactions. Co-crystallization is an alternative method used to circumvent the problem associated with the active formatical ingredient or API with low bioavailability. The problem statement for this project is nicotinamide have promising pharmacological properties, but it is low solubility and bioavailability limit its clinical application. By studying the intermolecular interaction in the co-crystal could reveal how modifying the crystal structure enhance these properties, leading to a better drug formulations. For objective for this project is identifying and characterizing the specific types of intermolecular interactions present within the nicotinamide and cinnamic acid co-crystal structure using Crystal Explorer. And next is analyzing the strengths and geometry of this interaction to understand the contribution to the stability and properties of the co-crystal using Crystal Explorer. For introductions, the nicotinamide and cinnamic acid co-crystal is a promising system with potential application in pharmaceutical, nutraceutical, and material science. Understanding the intermolecular interaction governing its formation and stability is crucial for optimizing its properties and designing new functional materials. This project aims to employ computational methods to investigate this interaction at the molecular level. And here is the material for this project, which is nicotinamide and cinnamic acid. For solvent, we use two types of different solvent, which is ethanol and propanol. Here are the first progress for first mixture of nicotinamide, cinnamic acid, and propanol. And here are the second mixture of nicotinamide, cinnamic acid, and ethanol. And here are the synthesis product from progress 1 and progress 2. And here are the XRD results. XRD pattern of the individual component for nicotinamide and cinnamic acid are compared to the pattern of the synthesized co-crystal. The presence of the new peak in the co-crystal pattern absent in the individual component confirm the formation of a distinct crystalline phase. The nicotinamide and cinnamic acid co-crystal with different solvents shows identical or same diffraction pattern. We can conclude that using different solvent does not affect the formation of crystal structure. And here is the FTIR result. We can see some important peak from the FTIR result. A peak at 3344, which is due to NH bending vibration of nicotinamide. A peak at 3138, which is due to the CH aromatic stretching vibration of both nicotinamide and cinnamic acid. A peak at around 1692, which is due to the CO bending vibration of nicotinamide and cinnamic acid, and a peak at around 1392, which is due to the C double bond C stretching vibration of cinnamic acid. From this result, we also can conclude that different solvents did not affect the formation of the co-crystal. For comparison, we compare from the synthesis co-crystal, which is X, and with the Y co-crystal, which is nicotinamide and cinnamic acid, with a different orientation. And here's a result for energies calculation from Crystal Explorer for both co-crystal. We can see the total energy for co-crystal X is negative 40 kJ per mole, and for Y is negative 27.6 kJ per mole. For the crystal structure, first, we compare the normalized contact distance. It normalizes the distance between atoms on the Hirschfeld surface by dividing them by the sum of the van der Waals radius of the atom involved in the contact. It mapped onto surface using a color scheme, with red indicating close contact, which is mean strong interaction, white indicating typical distance, and blue indicating longer contact, which means weaker interaction. Here is the denom for cocrystal X, and here is the denom for crystal Y. Next, we're going to compare its internal distance. It measures the distance from a point on Hirschfeld surface to the nearest atom inside the surface. Blue region on the Di surface indicate area where atoms are far from the surface, suggesting void or cavities within the molecules. Warmer color like orange, red, and yellow generally represent shorter distance. Here is the internal distance indicates for cocrystal X, and here is the internal distance indicate for cocrystal Y. Next, we compare the external distance. It measures the distance from a point on the Hirschfeld surface to the nearest atom outside the surface. The blue region on the Di surface indicates area where the molecule is not in close contact with other molecules, suggesting potential sites for binding and reactivity. Here are the external distance indicate for cocrystal X, and here are the external distance indicate for cocrystal Y. Next, we compare the shape index for both cocrystal. The shape index, it describes the local shape of the Hirschfeld surface, indicating concave region for red color and convex region for blue color. It highlights complementary packing arrangement with the molecules in the crystal, aiding in understanding molecular recognition and crystal packing. Here are the shape index for cocrystal X, and here is the shape index for cocrystal Y. And next, we compare the curveness. It measures the curvature on the Hirschfeld surface with high value indicating sharp edge or ridge and low value indicating flat or smooth area. Warmer color like red, orange, or yellow typically represent higher curveness, while cooler color like blue, green, purple indicates lower curveness. Higher curveness value indicates area with sharp curvature like bumps or hollows. Lower curveness value signify flatter region on the surface. Here is the curveness for cocrystal X, and here is the curveness for cocrystal Y. Next, we compare the fragment patch. Fragment patches are visually mapped onto the Hirschfeld surface, allowing you to see the spatial distribution and extent of interaction with different neighboring molecules. In size, a large patch indicates a significant area of interaction with neighboring molecules. For color, blue-green hues suggest attractive interaction, while red-yellow shades imply repulsive interactions. Multiple patch, different color patch on the same molecule indicate interaction with multiple neighboring molecules from different directions. Here are the fragment patch for cocrystal X, and here is the fragment patch for cocrystal Y. Next, we compare the 2D fingerprint plots. Plotting 2D fingerprint plots allow for the critical quantitative information on the intermolecular interaction in crystal to be retrieved. Here are 2D fingerprint plot for cocrystal X. And here is the 2D fingerprint plot for cocrystal Y. The obvious difference from X and Y is at NH interaction due to different orientation. For conclusion, propanol and ethanol were used as a solvent to successfully synthesize the nicotinamide and cinnamic acid cocrystal. When compared to published cocrystal with variant orientation, the synthesized cocrystal demonstrate higher stability with total energy of -40 kJ per mole. Additionally, new crystal phase for nicotinamide and cinnamic acid cocrystal were found using the characterization data. That's all for me. Thank you.